Alrighty, Methods 2021 tech-free multiple choice. Let's dive on in. Question 1, we've got a log equation and we're trying to solve it. So first things first, I guess the common mistake here for students would be to not recognize that when there's a 2 out the front, you can't actually do any log laws. So I'm going to have to use my other log law and rewrite this as log base 10 of x squared. So bring the 2 up the top, and then that's going to be subtracted by log base 10 of 3x. Okay, so now that I've got that set up, now I can do the log law where I have this subtraction, and that's going to be log base 10 of x squared over 3x, which will simplify to log base 10 of the x's cancel. So I've just got x on 3, which is going to be a. Question 1 done. Let's move on. Okay, question 2, we have a frequency table here about photocopiers. The question is, what is the probability that a given service required at least 10 but less than 20? So at least 10 is going to be 10 or more. So we're looking all the way up here. This one is still less than 20. The bottom one that I haven't highlighted is not less than 20, so it's not included. So the total frequency here, the total frequency here is 70, and in general, the entire total, if I add it up, it looks to be about 200. So therefore, the probability is going of x being at least 10, so 10 less than x less than 20 is going to be 70 frequency out of a possible 200, which as a decimal, if you divide them both in half, 0.35, and we've got B. All right, moving on to question 3. Okay, so we have integration. I find it helpful to just bring the constant out the front if I have a constant in my integral. So I can bring the 10 out the front. Now I just do integration like normal, divide by the derivative of the power. So I'm going to have 10 times e to the 4x divided by the derivative of 4x is just 4, so divide by 4, plus c, of course. The 10 and the 4 here, we can divide them both by 2 to get 5e to the 4x on 2, or 5 on 2 times e to the 4x plus c, which is option C there. Sometimes you have to change the formatting to match what the question's expecting, but that's life. Question 4. Okay, so it tells us that the second derivative of some function is this expression here. Is this expression here, 2x on 1 plus x squared, and it's asking us when is this graph concave up. So in general, the graph is concave up. F of x would be concave up when the second derivative is greater than 0. So what that means is basically if we've got a fraction, either the numerator and denominator are both positive. Positive divided by a positive is a positive, that's greater than 0, or they're both negative, right? 2 negatives dividing by each other is still a positive number greater than 0. But if we have a look at the denominator of 1 plus x squared, no matter what we substitute in for x, we're never going to get a negative number because we're squaring that value. So for example, 1 plus negative 3 squared is going to be 1 plus 9, which is 10. So there's no way for us to get the denominator to be negative. So if we need this to be true, right, the second derivative greater than 0, then we're going to have both numerator and denominator positive. So that means f of x is concave up when 2x is greater than 0, or in other words, when x is greater than 0, which is option C. Cool. Question 5, let's move on. All right, so we get a graph of a second derivative, and it's asking questions about the first derivative down below. This can feel tricky and something that you've not really been exposed to or taught, but all I want you to think of is that highlighter yet again, that moving from the first derivative to the second derivative, that's kind of exactly the same thing as moving from just the primitive function to the first derivative, right? They're only really separated by a derivative. So what that means is I'm just going to think of my second derivative that I've been given as the first derivative. And I'm going to think about my graphs down below, these ones here, as just the primitive function. So that can take me from a kind of unfamiliar scenario looking between the second and first derivatives and just bring me back to something that's more familiar. So I'm just going to be treating this as f dash x, so some derivative function, And then I'm going to be treating this as just f of x. And that's going to simplify it for me. So looking at this, if this is a derivative function, well, I'm going to be saying, I know that when a derivative function equals 0, or I'm going to highlight them here in pink, -1 and 1, those 2 points are going to be stationary points on the primitive or the original function. So if I come down here, b, these points here at -1 and 1, that's not a stationary point, so I'm going to rule out b. Similarly, if I come over to a, those 2 points are not stationary points, so I can rule out a. And I can see c and d both have stationary points there. So this is the -1 and 1, and also -1 and 1. So it could be c or d. So I need to recall upon a little bit more knowledge. Back to my derivative function, this bit I'm highlighting in green, that's all negative. So between those two stationary points, the gradient of the primitive function should be negative, a negative slope. So I come down here, I'm having a look at option C. Between -1 and 1, you can see that my slope is positive. It's heading up from left to right. So that's not going to satisfy, whereas D does. It's a negative slope from -1 to 1. So I'm going to eliminate C and choose as my final option graph D. Let's move on to question 6. Okay, so I have a probability distribution table of X, and it's a Bernoulli experiment with N trials. So the question is, what values of N, P, and Q would generate this probability distribution? Now, it's actually a really, really challenging question if you start thinking about 1 success, 2 success, 3 success. But what I want to focus on is, more importantly, 0 successes or 4 successes. I'm personally going to think about 0 successes, but you could do this in reverse by just thinking about 4 successes. It's up to you. What do I mean by that? Well, first things first, N is going to be the first one we're going to figure out. So it looks like N should be 5. Gut instinct, right, is 5 because we've got 1, 2, 3, 4, 5 different outcomes. So it looks like N is 5. But we have to consider what this means. So even though the numbers only go up to 4, we've got 5 different outcomes. We've got 0 successes, 1 success, 2 success, 3 success, or 4 successes. So it looks like it's going to go up to 5, but if 4 successes is the maximum, then I guess the number of trials that we're doing is 4, right? If N was 5, then we should have an option for 5 successful trials. We currently only have the maximum option of 4 successes. So what that means is, even though there's 5 numbers there, we're going to ignore that and say N must be 4 because the maximum number of successes is 4. Okay, so I'm going to ignore C, ignore D where N is 5, and focus on A and B. Now to figure out P and Q, you just need to figure out one of them because they sum to 1. So if you can figure out one, you can figure out the other. Also, because in the multiple choice answers, they are different. So if you can figure out one, you have the answer. So I'm looking at 0 successes, as you can see highlighted in green here. So for 0 successes, I'm going to have N commas, or NCR, but it's going to be 4, 0. So this is 4 attempts, 0 successes. The probability multiplied by the probability of success, which is just going to be P, I don't know what it is yet, to the power of how many times we succeeded, which was 0, times the probability of failure, Q, to the power of how many times we failed, which was all 4 times, right? If we had no successes, we failed all 4 times. And apparently, that probability gives us 1 over 81 as a fraction. So what we need to do is simplify a bit. 4C0 is just 1 times P to the power of 0. Anything to the power of 0 is just 1. So 1 times Q to the power of 4 is going to equal 1 over 81. So our question becomes, what do I times by itself 4 times to get 1 over 81? Well, if I take the 4th root of both sides, I'm essentially going to take, and I'm going to do this fully stepped out because this is a kind of complex, unfamiliar question. If I take the 4th root of 1 over 81, what that means in a fraction form is I'm going to take the 4th root of 1, and I'm also going to take the 4th root of 81. Now, what times itself 4 times to get 1? The only possible answer is 1. And straight away, we actually have the answer, right? Your 2 options, A and B. In A, Q is 1/3, and in B, Q is 2/3. but we just found out our numerator is 1, so we can straight away finish, but may as well go ahead and show that if you times 3 by itself 4 times, so 3, 9, 27, 81, you are going to get the fourth root of 81. So 1 over 3 is Q, so now I'm going to highlight A. But notice I could have stopped as soon as I got that numerator of 1. But happy with that. Hopefully that made sense. That's kind of a tricky question. It's a very hard one for multiple choice, but hopefully it made sense. Let's move to question 7. Hello everybody, Future Mark here. I'm editing the video this morning, which is the next morning after I recorded it, and I realized I actually skipped question 7 by accident. So here it is, hence the shirt change, but I want you to have every single question. So the integral from 1 to 3 of 2x plus 3. First thing we're going to do is just integrate this thing. So the integral of 2x plus 3 dx from 1 to 3 is going to be equal to, now 2x, you raise the power, so it's going to be x squared, divide by the new power of 2. So it's going to be 2x squared on 2, but of course those 2's cancel and I'll just have x squared. And then plus 3x. So it's going to be x squared plus 3x. I'm actually going to rub out that because it's going to look ugly. X squared plus 3x, and we're going to evaluate it between 1 and 3. Sub in 3 first. So we're going to get 3 squared plus 3 times 3. And we're going to subtract from that 1 squared plus 3 times 1. So that's going to be equals 9 plus 9, which is 18. And then minusing 1 plus 3, which is 4. 18 minus 4 is 14, which is going to be question C. Answer C. Alrighty, sweet. Good to see you from the future. Let's go to Past Me. Question 8. Okay, so we have a continuous random variable, and it has a probability density function, and it's asking us to find the mean. So I know that the mean, highlighter once again, the mean of a PDF is going to be x times the integral of x times the function of x dx integrated between the two boundaries, in which case this is going to be the integral of x times 3 on x squared dx between 1 and 1.5, or 3 halves. That's going to simplify though, because the x's are going to cancel, and I'm going to factorize the 3 out the front, and I'm going to have 3 times the integral of 1 to 3 on 2 times of 3 on x dx. So when I do that integral, I've factorized the 3 out, so it should just be 1 on x, which is going to integrate nicely into an ln. So I'm going to get 3 times an ln of x, and I'm going to have to evaluate the ln of x between 1 and 3 on 2, which just means sub it in. So that's going to be 3 outside of ln of 3 on 2 minus ln of 1. Now, ln of 1 is just 0, which is a nice one. That means it's just going to be 3 lots of ln 3 on 2. But that's not one of my answers. None of my answers have the 3 out the front, so I'm going to have to use my log law like in question 1, where I bring it to the power. So I'm going to have ln of 3 on 2 to the power of 3, which means I'm going to cube the numerator and denominator. 3 cubed is 27. Only possible answer is B. Alrighty, sweet. Moving on to question 9, 2 to go. Alright, our basket contains 10 green apples and 30 red apples. Oh, good. We're going back to year 8 probability. Excellent. It says 3 apples are drawn at random from the basket with replacement. So that's good. It means the probabilities aren't changing every trial. It says determine the probability that exactly 2 of the 3 apples are green. So if I'm choosing 3 apples, and I'm choosing, hopefully, 2 out of 3 being green, that means I'm going to have green, green, red as an option, green, red, green as an option, and also red, green, green as an option. Now, each one of these is going to have the exact same probability, but there are 3 of them. So essentially, I'm going to get my answer shortly and just multiply it by 3, because there are 3 different ways to achieve this outcome. So let's just choose the first one, green, green, red. The probability, I'll just write this off to the side, of getting a green, if we have 10 out of 40 apples being green, that's a quarter. And the probability of red, if we have 30 out of 40, that's going to be 3/4. And so therefore, probability of a green, green, red is going to be a quarter times 3/4 which is going to be 3 on whatever 4 cubed is. 4 4s is 16, 64. 3 on 64. But don't forget, as I mentioned, I wanted to multiply my answer by 3 because there's 3 different ways to achieve this. So just times the numerator by 3. So I get 9 on 64 as my answer. And yes, that is one. It's B. Last question. Okay, handspans of teenagers are approximately normally distributed. Mean of 15, standard deviation of 2. And it's asking us which of these groups is expected to be the largest. Now, I always recommend to my students, draw it every single time. If you are one of my students and you're watching this video, tell them down below. I tell you that every single time. Draw your your normal distribution. Doesn't have to be nice. Just draw it, put in your mean, and then just maybe off to the side, write your standard deviation is 2. So that way we can visualize some of these things. In fact, I'm going to go ahead and copy this 4 times. Okay, so I've copy and pasted the same distribution 4 times because I want to demonstrate this graphically so that it's clearly understood. If we look at A, teenagers with handspans that are between 7 and 11 centimeters. So if I put, I'm going to go A here, B here, C here, D here. So if I'm looking at graph A, 7 and 11 is going to look something like this, right? At the very least, both of them are to the left of the mean. So if I highlight this here, even if I don't understand that it's going to be that small, I can see that because it's to the left of the mean, and the mean represents the middle point, so that there's going to be 50% to the left and 50% to the right, I know that this region in here is going to be less than 50%. That's all I know at this stage. I could do some calculations later if need be, but at this point, it's less than 50%. B, teenagers with handspans that are between 11 and 15. So this one's going to be a bit bigger, probably, but it's going to be between, I'll try and put that 11 in the same spot, so about there. This one here I'll do in pink. It's still going to be less than 50% because it doesn't go over the mean, right? So the mean all the way down to 0 will account for about 50% of the population. So this region that I've just colored in here, this is also going to be less than 50%. Part C says teenagers with handspans that are between 13 centimeters and 17 centimeters. So that's going to be approximately here. And I'll come back to this one because it's on both sides of the mean, so I can't just say it's less than 50% right now. Let's investigate later. And part D on the right, it says between 17 and 21. That's similar to the other two, except they're above the mean this time. But that's also going to be less than 50%. So the real question is, if I can't, first of all, can I figure out what the area between, what was it for C? It was 13 and 17. Can I figure out what that area is in a tech-free environment? If not, how do I distinguish between the other three? Well, I can, fortunately, because it tells me that the standard deviation is 2, and 13 and 17 are both 1 standard deviation either side of the mean. And we know, and hopefully you know, if you don't, 1 standard deviation either side of the mean, or the probability that -1 is less than Z, which is less than 1, which is the standard normal, is going to be approximately 0.68, or approximately 68% of data values lie within 1 standard deviation either side of the mean. So that means this yellow one here is approximately 0.68. Now, if all the other ones are less than 50% and this one is 0.68, then it's clear that C, and there's a reason I did this one in yellow, C is the answer to this question, the one with the largest group. So, methods 2021, tech-free multiple choice done and dusted. Hopefully you found that valuable. If you're enjoying this series, make sure you subscribe to the channel, and at the very least, like this video. Make sure you share it with your friends if you think they can get value out of it. If they're doing methods, I'm sure that they can. Okay, I'll see you guys in the next video.